Okay, we have done straight line graphs, we have done ellipse, we have done circles, we have done rectangular hyperbola, we have done hyperbola graph, we have done exponential and logarithm, we have done sine. Today we're going to do the cos, we're going to do the tan, the cosec, cot, and then parabola. Cubic function graphs, we're going to discuss it while we're doing derivatives.
How about that in 1.5 hours?
Talking about the parabola.
No, the cubic one.
Cubic.
So parabola we do now. Okay, so let me get the sheet, right? So now we're looking at the cosine graph. In terms of yesterday, what we did with the sine graph, do we understand it, right? Your A term is your amplitude. To work out the period of it, you take 360 over B. Phase shift is minus C over B. Your 0 points in terms of sine graph would be?
Minus 360, 180, 180, and 360.
Yeah. Minus 360, 180, minus 180, 0, 180, 360. Right? So 0 points, you know where it is. If it's a D value, if it's a positive D, you move your graph up the y-axis. If it's a negative D, you move it down. Phase shift refers to left and right. Now the same thing is also applicable to your tan graphs, and it's applicable to your cos graphs. The only thing with tan you won't have to worry about is your okay, when I come there, I get it, right? Cosine, right? Now we are cosine. General formula for it, y is equal to a cos of bx plus c plus d. Looks exactly like how your sine one looks,
So cost is
except now it's cos. So it's the exact same thing. A will be your amplitude, B will be your 360 over B will be the period of it. Phase shift is minus 360 over B. Yesterday we all understood that how it shifts left and right, up and down,
Yes.
all that sort of thing. So cos would be easy, right? So your in general your y is equal to cos graph. How does it look? Y is equal to cos x. So this here will also have 0 points. Okay? But the 0 points for a cos graph are okay?
So it's out of phase 90 degrees. It's out of phase by 90.
Yeah.
From the cos, from the sine.
So if you start from negative 270, just add 180 and you keep on getting your 0 points for the cos graph. Get what I'm saying? Okay, for sine graphs, start from negative 360, add 180. You'll get all your 0 points for sine graph. For cos graph, start from negative 270, add 180, you will get your 0 points. Okay? That. And if you subtract negative 180, you'll get the 0 points going to your left. Okay, so in general, your cos graph looks something like this.
Sorry, John, I just want to answer.
Yeah, go ahead.
So, just say in the exam you have to, if they give you to draw a graph, you have to list, like, you say A, the period, phase shift, like how they got it set up in the notes.
See, I was seeing the past year papers, right?
Yeah.
If they tell you draw the graph of y is equal to
Yeah.
cos x, right? And it's 6 marks.
Yeah.
They don't
What about the
They don't show the calculation
Yeah.
part in terms of it. They just show the graph, and I told you how you get that 6 marks, 2 marks for axis. Remember, your intercept calculation would have been done, and you would show it. Now, I think when you show that value, that's the mark that's given for you calculating intercepts. I'm sure, like for these ones, it'll obviously be different. They'll give you a mark for having the correct amplitude. They'll give you a mark for if you did a shift up, if you needed to, you get marks for that, right? So in terms of the calculation, you obviously have to work it out because how else you're going to get to the numbers. But yeah.
No, but sometimes you can see it with the.
Like how we said yesterday,
Yeah.
in terms of your amplitude will be this, your y values will be that, your 0 points.
She's laughing at me. I'm telling you, sometimes you can see it, you don't have to even do any
Some
calculation.
of us have to calculate.
Yeah, no, it's either or.
Yeah.
It's if you can see it
Yeah.
and you don't want to do the calculations, which I don't suggest because it's easy to make a mistake. do the calculation. Certain things here and there you can maybe skip doing the calculation on, like the amplitude showing it and all that stuff. But that 0 points, that's where you may make a mess up. So, but your 0 points, if you remember, like this is the 0 points, and if you work out that phase shift, and you end up with -5 degrees, you know that it will be -270 -5. It will be -90 -5. But you also need to, yeah, okay, that's
Yeah, it's fine, it's fine.
basically it. Okay,
Thank you.
it's fine. What else? Right, so I said one is -90.
Mark me down in the exam. I know it's more. How I got to this?
So remember with your sine graph, right? It started from your 0 line or your middle line, right? With the cos graph, it starts at your upper value of your amplitude. Okay, so this would go
Other way around.
and it will carry on like that, and on this end it would go. Which is why when you put cos of 0 into a calculator, you get a value of 1.
270.
Sorry.
Yes.
Eh? This is your value. Okay? Amplitude in this instance would be what?
1,
1, right? Phase shift?
0.
0. There's no phase shift, right? So wherever your 0 points are, it will be there. Is it shifting up or down? No. So this here is your general form of a cos graph. Okay? Be okay with this?
100%.
Okay, let's do an example there. Y is equal to 4 cos 2x
-10.
minus 10 minus 1. Okay, looking at this then, the information that we have, right? Your amplitude is equal to what?
4.
4. The period of the graph is equal to 360 divided by the value of b, which is
2. I mean, 180.
360 over 2, which is 180 degrees, right? Meaning that the period for one wave is now, see over here, the period for this wave would have been 360, so it would have been from, say,
What would be? 270 divided by 2.
Hmm?
What would be?
no, for this one here, the period would have
Oh,
been
okay.
360, right? So the time taken for you to make one wave would have been 360. So it would have been like maybe from here all the way going there. Now, if your period is 180, this will be probably squashed up into something like that. You'll get it, right? Okay.
No, but sorry, man, I'm just saying, cos is the other way around. So you took it from -90 to 270.
Which is how many degrees between? Minus 90 to 270.
360.
360. Right? Because from minus 90 to 90 is 180, and then from 90 to 270 is also 180. That's 360. That will be the time taken for one wave. That will be the period. Now, in terms of that, now your period is now gone smaller. So this part here will basically squash up.
All I'm saying is that from -90 to 270, that's a sine graph. Huh? Does it affect it?
No, I'm just showing you at any point. Like
right.
at any point, even if you started from 0
Yeah.
and you went to 360, it will look like that. I'm
Okay,
just showing the period of a graph, right? Okay. That was period. Phase shift, right?
Is 5
Is equal to minus C all over B, right? This would be equal to minus 10 all over 2, right? Which would be 5 degrees. And then it shifts, would be equal to, it actually phase shift down, right? -1. So that's the information you could have used if you are visually looking at the graph and you want to show it, and then you basically use your 0 points, you add your phase shift to it, and then you carry on. Okay? Now, if we're doing it calculation wise, we would have set our y-intercept. That's x equal to 0. So you would have ended up with y is equal to 4 cos 2 times 0 minus 10 minus 1. 2 and 0 is 0, cos of negative 10 is? Okay, just put that on the calculator. Zero point?
No, sorry.
Yeah.
Didn't you tell us around 8 or minus 1?
No, this is for intercepts.
Yeah.
This is not for 0 points. 0 points is when we're looking at this. This is, I'm just showing for the y. You know when if this shifts and it will cut the graph somewhere along here, that intercept I'm working on.
I'm getting a different answer.
Yeah, no, Earth said that was for the inside part.
The inside part only.
What's that? 2 point something.
3.9.
I think with this flow,
2.9?
0 points first and then go to
3.
how it is
Yeah,
yesterday.
you normally
Yeah.
get that
So
too.
normally you normally work out the 0 points first and then you go to the x and y. So
Yeah, but let's do intercept first, right? Right. Now let's look at 0 points.
No, wait. We have like 2.9. Oh, you weren't supposed to put the minus 1 there.
Where you were?
No, you told
also
me
got
to
2.939.
No, you said you
No, you
put the
told me to
1.
minus 1.
No, you put minus 1.
So it's not times minus 1, it's minus 1.
No, but you don't minus 1.
You have to minus 1.
Jesus Christ. Guys, I'm working on the intercept. Not 0 points or anything. This is just intercept. For your intercept, you let it equal to a formula, you let the other value equal to 0. Right? This is not 0. This is 0 points where I'm coming now.
2.9.
Okay? 0 points is all these points here. Y intercept is where it cuts the graph when x is equal to 0. Remember with the space shift, it's going to move 5 degrees to the right, 1 up, right? And it's going to cut the graph at a certain point on your y-axis. Yes?
Okay.
So that's the point I'll show you when I'm drawing the graph, right?
Is this specific to cosine?
No, even for the sine. Remember yesterday asked me if we have to show the
Yeah,
graph,
that's
show
And
the
we
value.
didn't put
That's
it.
the one we didn't do like yesterday.
But we didn't put it.
So you see where the whole thing confused, right? When you're setting it up,
Yeah.
0 points first. You see everybody was had that same this thing to work out the not using the minus 1. You know they've got that
Yes, that's what you told us yesterday.
Because that's 0 points.
No, working out the x and the y is it? But anyway, we'll tell you. See, look at yesterday's examples.
so it is 0 points, but you're calculating for x and y on the for the 0 points, right? Then x and y you're calculating your degrees, right?
See, it's
Okay,
30 there.
the-
Same with timber. Remember, I asked about timber.
No, you take that
Yes.
as y intercept for
No,
the
I can't take it up. Yeah, you're not listening. I'm saying, let's see it. When you do the calculation, right? For any graph, what's the 2 points you use?
x and y.
X and y intercept, right?
Okay.
To work out your y-intercept, you let x equal to 0. To work out your x-intercept, you let y equal to 0. With these graphs here, we have something called 0 points, right? Always at certain values, this graph, if you put it into the calculation, it's going to equal to what? 0. So, intercepts is one calculation, right? Like I said, if this graph had to shift up and 5 degrees to the left or right, this line is not going to cut it at that amplitude, it's going to cut it maybe a little bit before that, or a little bit after that, right? That's just your intercept values when you're drawing it for accuracy, right? 0 points, when you're doing 0 points calculations, 0 points, you will only take this part here that's inside the bracket, because cost of whatever values may cost 0 would be whatever angle you work out here, okay? And then you would equal it to this, so you would have said 2x minus 10 is equal to negative 270. 2x minus 10 is equal to negative 90. 2x minus 10 is equal to 90. 2x minus 10 is equal to 270.
Yeah, that's what we just spoke about yesterday. And then what would you just calculate it now is what we didn't calculate yesterday.
Remember he asked me and he said we need to show it.
Yeah.
That's what I'm showing.
Not me, not me.
Okay,
No,
it's-
no, Nikki, he
No,
did.
it took too much locals.
He
No,
did.
No, it's just go.
He did
minus
show the
270
y
minus
intercept.
90. Yeah.
it didn't show us.
No, it's here. That photo.
Whatever
Yeah,
you-
because you and Earl were talking that it.
No, I'm saying,
No, you
I'm
asked
with you.
Just see if I
That's
posted
what
the photo.
you're showing us, like, yeah, Is that-
Okay, but guys, let's
Yesterday.
go back.
We have to calculate.
Okay, let's carry on with the 0 points. Just carry on and move. The guys will pick it up. The moment you do it, the example there, just put minus 270, minus 1990, 270, and carry on with that phase shift.
Okay, I'm running out of space there, so I'm right from this side, right? Our 0 points are what?
Minus
Minus
270,
270,
minus 90, 90,
90, and
270.
270. Please don't mix it up and think that there's also 0 degrees in it, because that's not a 0 point. For x value of 0, you get a y value of 1, right? So you don't include that, because for sine it's
It was 0.
negative 360, negative 180, 0, 180, 360, right? So now whatever for 0 points, whatever is inside that cost bracket, you let that equal to the 0 points. You're okay with that, right?
Yeah.
Okay. So then you'll say 2x minus 10 is equal to 2x minus 10 is equal to 2x minus 10 is equal to 2x minus 10 is equal to. If you take negative 10 across, you're going to end up with negative, positive, negative 260 you end up with, right? Divided by 2.
130.
Yeah, if you take 10 across, it becomes negative 80.
Yeah.
X is equal to negative 40. Here, if you take 10 across, it's going to become 100. X is equal to, if you take 10 across here, it's going to become 280. X is equal to, right? So these are what? The 0 points. Right? So that's where, when the graph you're drawing it, it's going to cut it at 0. So
Like
all
an
these
like
here
an x-axis.
will now be these values. And remember, because of the period now being smaller, that's why these values are so much smaller than what these values are. Okay? Okay. So right. Okay? Where will your middle line be drawn? At what value? The middle line.
So,
Minus 1, right? Because it will be that value of d. So my middle line is now going to be minus 1. My upper amplitude would be what?
minus 1 plus 4.
Which is 3, right? Because my amplitude is 4, right? Amplitude is the distance between your middle line and above or below, okay? So above would be 4 minus 1, which will give you a value of 3, right? And below would be
Minus 5.
Minus 1, minus 4.
minus 5, right? Yeah, I'll understand that. Okay.
Right? No?
So remember above we said
Okay,
from the,
plus 4.
and then it will be minus below, right?
Yes.
Right. 0 points. Where our 0 points are?
Minus
Negative 130. Negative 130. So 0 point is there. Right? Next negative 0 point is negative. So another 0 point is there. Next 0 point is 50. 50 degrees, another 0 point is there. Next 0 point is another 0 point is there. Yeah? So far we made use of all the information that was given to us. Your cost graph starts from from the higher amplitude.
Higher,
But remember where your y-intercept would be at x equal to 0, so your y-intercept would probably cut it maybe somewhere there. With your phase shift, remember this whole graph moved 5 degrees to the right. Okay? So instead of it starting here, it'll actually start 5 degrees here. You understand that?
Yeah.
See here, normally it starts at 0. Your phase shift will cause this whole thing to move 5 degrees to the right. So if instead of starting there, it probably started there. Get it?
Wait, sorry.
But you just worked out the.
Start from the 130. Won't you start from the 130 and continue with your curve?
Yeah, you can, but I'm saying from your y-axis.
Oh, you're just trying to show.
Yeah.
But wait,
Can I
cuts
maybe help you a little bit? So that's where your zero is. So your highest point will be in between those two. So if you go in the center and you bring them up, put a point down there on your highest amplitude, then you'll get your points and then you can just join them.
Right? All I'm basically showing you, okay, but this is how the graph would look, right? It will look, it will cut across your y, it will go there, it will come like this. That's how the graph would look, right?
Yeah.
What I was trying to say was, remember how this graph started on your y-axis? But because we have a phase shift of 5 degrees, this part here shifted 5 degrees. So that's where that would normally be. Okay? But that's how your graph would look.
So we've got to actually like show it like that, not go. We have to make sure we don't cut on the y-axis right?
You have to show it.
And you've got
Yeah.
to show that 5 degree
Yeah.
shift on your curve.
Oh yeah, yeah. And how you would show it
Yeah.
is because see when I pass through this point here, that point basically already, I can't turn on this. Obviously have to turn on the amplitude line. So it will guide me towards there, and when I touch the amplitude line, I can start turning back down.
But that intercept there, you've already worked it out. Where x is
That
equal
intercept
to
was
2.939.
That intercept was
2.939.
x is 0 and 2.939.
939. Yeah.
Okay.
So that gives you a guide.
That's what I'm saying.
Yeah.
The y
Yeah.
will give you the guide when you draw.
Yeah.
You understand this? Okay.
Okay.
Good. It's
And you're done now?
That you're
Done.
done. So okay, only thing you would have said was here is equal to y is equal to 4 cos 2x minus 10 degrees minus 1. This is your x-axis. This is your y-axis. Shape is right. You got your critical points in this here calculation would have been your 0 points, that y-intercept, showing these values for your amplitude, and that middle line. Right? Those are the minimum amount of values you need to draw this graph. Right? If you want to put more values, you can for accuracy, but
So I just thought about something. Normally these always used to end up putting turning points in, but we don't have to do that, huh?
that,
Coordinates,
no.
yeah.
That would have been halfway of your period would be a turning point.
Yeah. But I'm saying you don't have to add it onto the diagram. Yeah.
Oh, that's what you're saying. Oh no, you don't need to worry about that. They're not testing you on that. Turning points, I think they're gonna actually test you in
Next cube,
differentiation.
yeah. The
But for parabola, we work on the turning point.
yeah.
Guys, are we okay with that? Anybody confused? Chamba, are you okay?
Yeah, I'm good.
You sure?
Yeah.
Okay. Okay, gonna do tan graphs. The problem with tan is not 0 points and not 0 points to remember.
Give us one just to do. Huh?
Let me pause the video. Take it back. And so now we're looking at the tangent graph. Okay, so now we're looking at the tangent graph. Okay, so same general formula as the sine and cos. Only thing that's different is obviously you replace that with tan, right? So 0 points for a tangent graph. So your 0 points for tangent. right? So that's your 0 points, right? Your 0 points is like how your sine graphs are. Okay? Now remember, these graphs can continue forever. So that's why I wrote plus 80 on the end of that side. On this side it would have been minus 180. So on the left hand side of 0 you would have said minus 180, on the right hand side you would have said plus 180, understand? Okay? That's basically it, right? That's your 0 points field. But with the tan graph you get points where it's not equal to 0, where this graph just completely, you get math error if you put the value into the calculator, right? So you also need to learn those values. And you see, anybody ever saw a tan graph before?
Yeah.
Okay, look at the graph, guys, on page 156. Okay, you can see the line goes like this. It has a break there, and then it goes like this again. Can you see that? Right? Anywhere on the graph, if you look at it. This point here, if you put it into your calculator, it comes up as a math error because the graph doesn't cut there at all. Right? So those points are, I'd say it's where there's no value of x.
That look like worms.
Yeah. Like, take out your calculator and put tan of 90. Error, right? Tan of 270 will be the same thing. Tan of negative 90, negative 270, that sort of things, right? And you'll see why it's nice to remember that, because it makes your life so much easier when you're drawing a tan graph. Okay? So, so the values you need to know is so x won't be equal to negative 270, negative 90, 70, and so on, right? So what can help you remember this is your 0 points for this is like how a sine graph is. The values where x is not equal to a value is like what? Cos 0 points, right? So you can kill two birds with one stone. Right? Now let's draw. Let me show you how you can just understand what I'm saying. Right? These are like your 0 points for sine graphs. And these are like your 0 points for cos graphs. So in the tan graph, your 0 points are actually your sine values, and it's not equal to a value at your cos 0 points. Okay? So y is equal to tan x. Right? Y is equal to tan x. We'll do something like this. Right. Now remember I told you it's not equal to values at minus 90. So this is minus 270, minus 90, 90, 270, so on, so on, so on. Right? It's equal to 0 at which point? At 0, at negative 180, and then so on this way, like negative 360 and onwards. 0, and then over here 180, 360 onwards, right? All you need to do when you're drawing this graph, draw it between these lines where it's not equal to x value. You get it?
Yes.
Right? Okay. That's a tan graph, right? So looking at this, what can you tell me in terms of the information that we learned before? Does this have an amplitude?
No.
So your a value won't necessarily affect. You don't really need it when you're drawing a graph, because these two lines will continue forever, right? And all of these lines will continue forever. Okay, so amplitude doesn't really affect it. Phase shift will affect it, and whether you shift it up or down, that will be the only things that affect it. Okay, let's do it. So you understand how a general tan graph would look. Let's do an example, right?
You want we take 4 and poster, then you can erase it.
No, keep it. Yeah, right. That's it. Okay. So this is your example. Okay. So for y-intercept, you let x equal to 0, right? So you would have ended up with 2 tan 3 times 0 plus 15 degrees plus 2, which is the only thing when you're working on for tan graphs, but it's just a little bit of a longer calculation compared to the other ones. Okay, actually
2.5,
Perfect.
3, 6.
2.536.
Yeah.
I know. What you? Oh, I don't believe it.
Check.
Right.
Check. Can you see?
What you got? Same price, huh?
Yeah. I don't know that one.
I think I'm doing something wrong. That's right.
Okay, so yeah, we got our y-intercept, right? We just need our 0 points now in order to work it out. Because okay, so we need our 0 points and we need our points where x is not equal to a value. So exactly like how you would do 0 points, you do the same thing for x not equal to values. And why I say do that is because doesn't these lines help you when you're drawing your graph? So you don't overlap each other, right? So let's do 0 points, right? And the thing is, I'm only going to do between negative 180 and 180, right? If you can do, if they give you a bigger range, like between negative 360 and 360, you'll obviously have to work out for more values. I'm giving you a range of negative 180 and 180, right? So, your 0 points, you're going to end up with 3x plus 15. Understand that?
Yes.
So it's going to be 3x plus 15 degrees equal to negative 180 degrees. 3x plus 15 is equal to 0. 3x plus 15 is equal to 180, right? You could have done it further if you wanted to. So, take your 15 across, you're going to end up with negative 195. Negative 195 divided by 3, 65.
Yeah.
Negative 65.
Yeah.
Yeah, you're going to take your 15 across, it's going to become negative 15. Right? Divided by 3 is going to be minus 5. Yeah, you take this across, your 15 becomes 165. 165 divided by 3,
55.
okay, that's our 0 points. Right?
Yeah.
So now these values, yeah. Oh, okay, let's show the phase shift, right? Let's show it. So the phase shift.
Well, why?
Hmm?
Okay, why we not going to go to the x? We'll do that first.
No, I'm just saying we should have done it when we were doing. I'm not saying. Okay, never mind. Here. Right? So these are the values where x is not equal to a number, right? It's going to be not equal to a number at. So in this instance, if I took this,
90 and
this, and this,
minus
I'm going to work out for minus 90 and 90, right? Okay, so it's going to also be 3x plus 15 is equal to minus 90, right? Then it's also going to be 3x plus 15 degrees is equal to
Positive.
positive 90. Huh? No, remember I said over here, for when x is not equal to a number, there's no 0. Right? Like how the cost is. Right? So, you take your 15 across, it becomes negative 105. Negative 105 divided by 3 is going to be 35.
Yeah.
Negative. Here, you take this across, 90 minus 15, 75.
Yeah.
Divided by 3 is going to be 25. So now we got our points that we need. We needed this point, that point, that point, those points, right? Let's draw the graph. Can I take out that? Okay, so let's draw the graph, right? you would draw your axis first. This is your y-axis. This is your right. Looking at the graph. The only thing I told you was amplitude won't affect it, right? Everything else still affects it. Look at the d value. Your d value is 2. What does that mean? Your graph shifts 2 up. So your middle line is now 2 up. 2 units up, right? So now your middle line is here, which is 2. Okay? So let's put our points where it's not equal to a value. It's going to be at negative 35 and 25. So that means your tan graph should never touch that line. Your tan graph should also never touch that line. Right? Understand? You all with me?
Yeah.
Okay, right? Y-intercept is 0 at 2.536, which is, if this is 2, let's say 2.536 is there, right? And then our points, your 0 points, it's going to be negative 65, let's say it's somewhere here, it's going to be negative 5, which is somewhere here, and it's going to be 55, which is somewhere there. So now you just need to draw it. So what you'll do, you'll draw. You have to read very badly, right? But that will continue out there.
Move that thing a bit more left. That's right. Yeah.
Right? Right? Okay, right? That line there will obviously continue until you have another dotted line here. It would have been for when you were working out negative 270, right? And then this line here would be, it will continue here if you worked out at negative 270, this would have been 270. Right? A period in a tan graph is basically from here to here. What your period would have been? It will be 360 over the value of b.
Yeah.
It will be 360 divided by 3, which is
90. No, 2. Sorry. Let me just calculate.
120. Then from negative 35 degrees to 25 should give you 120. No, that won't work. It will give you 5.
6 minus 65.
Yeah.
65 to
55.
no, from the first one.
Sorry, the 0 points. I'm looking at other lines. So from minus 65 to 55 should have gave you 120. That would be the period of it. I don't know why I looked at 0 points. So for a tan graph, this is basically the period where you have, it's basically when 2 of those waves are formed. Right? Remember with this plus that would have gave you the other
Between
wave.
minus 65 and 55. Right?
Right? That's tangent graphs, guys. Are we okay? So we all understand how to draw a tangent graph.
Yes.
We all understand the values associated with it. Is anybody confused? Does anybody have any questions?
Yeah, so when are we going to have half a squiggly on your one side, like how you drew it?
No, I just drew it like that because I didn't
Will
work
it
on
always
the,
be a full thing?
Yeah.
Always.
I just talked to you like that because I didn't work on this line here. So I don't know how far I'm going to carry on with it.
Okay.
No, 2 years and 2
Yeah. See, even them too, they never worked out the.
So it's
that
not meant
last-
to be like that. It's
Yeah,
just
it would
something
continue, but you don't know how far to draw it until your x-axis because you won't know where
That
to stop.
it will carry on to the infinity like that.
Yeah, no,
Yeah.
that's what I'm
At the
saying.
end, yeah.
When you're drawing it, so you will have a drawing where it doesn't.
But see, in the paper, right?
But the right thing is to put the asymptote there, to put that dotted line there, right? And complete it all the way down.
Yeah.
Draw it.
Unless
They give you a range.
So if they give you a condition, right? And they told you draw the graph of y is equal to 2 tan x 3x plus 15 degrees plus 2, and they tell you x lies between negative 180 and 180 degrees,
Then it will be like
right? Then your calculations will be done according to something like that. Or in this instance here, just say it lied between negative 70 and
Draw
70.
that from 0 to 60, they reduce that much.
They will deduct a mark because you wasn't following the range that was given to you.
1 mark is fine.
Why lose a mark? That means you did more work than you're supposed to. And you're getting the. You're getting robbed and giving them something. Helping the people.
That's how that's right.
So that wasn't all of Chick graphs. I thought I was gonna say that was Chick graph and I realized.
I got all inverses.
Yeah, but she's just gonna go through the theory part. Can't read all the whole table and stuff. You wanna take it on first, then we go through it, or you wanna go through this part then take it on? Okay, take it on. Take it on. Yeah, positive. 2 now we're 2 units up, right? It shifted
2 units up.
2 units up. Where I drew my line, did I draw it in the middle line? No, I drew the x-axis, which is incorrect, right? So this value here was our center point. It was, what I said it was?
65.
This was minus 65. So that is actually the center point, right? The other one was minus 5. If minus 5 is here,
Okay.
that is the center point, that is the y-intercept, and then if, what is the other one? 55.
Yeah.
That is the center point, right? So now when you're drawing it, it should have looked like,
Yeah, cute.
thank you very much, glad you got that. Right. See, now you know graphs, no? Started. Right? Good or six. I don't know why this always happens to me.
But-
I'll see it shift up,
Yeah.
but I'll still draw it in the x-axis. Yesterday I did the same
Yeah,
thing.
why?
But
You
where- but
also
where-
wanted to put down the information and then you stopped.
But where it
Remember you
crosses,
said you wanted to put it?
Yeah.
where it crosses the x the y axis, it's 2.536. Am I right?
If you let this equal to 0.
Yeah. So the point is supposed to be 2.5, not 2.
No, it is. 2 is the
No, 2 is this middle leg. Yeah.
Okay.
2 is.
Yeah,
yeah.
what I'm saying
It's
is
just
the-
that, yeah,
the
here
process
is
2.5. Okay.
uh,
just understanding.
0 and 2.5.
Okay. I was doing it for my
Yeah, so it helps you when you're getting the shape.
Yeah,
That's why
yeah.
you remember the first time I drew it, it looks so off.
yeah. Because
But
you
now it's because it's accurate. It's got it.
Oh, he's right.
Okay, guys, we've got that. Okay, now take that.
we're getting this.
I'm really glad you noticed that and we didn't. Well, that means you're understanding what's going on. You got that? You got it?
Yeah, I'm okay.
How's it driving this morning?
Nah, that's back to normal.
You sure?
Mm.
Okay. Good to see you.
So he had good lessons last night, yesterday. So he didn't want to kill himself this morning.
Is a graph a functional or a relation graph? That one that we just drew last.
Function.
It'll be a function, isn't it? For every value of
Only one.
Right? For every value of x, how many values of y you get?
you get 1.
1. So it's a functional graph. Continuous or discontinuous?
It's discontinuous.
And you can look at the graph and see it is discontinuous because there's a break,
Yeah.
right? So you can see the entire graph is a discontinuous graph. Okay?
The range.
Yeah, but for this one, okay, exactly like how I drew it, right? Looking at the graph, what's the range of the graph?
Infinity both ways.
The range, oh yeah, infinity both ways. Sorry, I thought it was some reason. Range would be infinity both ways, right? Negative infinity, less than y, less than infinity. Because remember, it goes all the way to infinity. That the two lines, the arrows would continue down, continue up. Your x range,
Domain.
Domain.
Will be 180 minus 182 plus 180.
Looking at the graph.
Oh, so it'll be minus 65 to 55.
No. It will be minus 65 less than equal to x less than 35, negative 35. Because remember x, the value of, so the, yeah, because of the break, right? So your range of this graph would be negative infinity less than y less than infinity. Because if you take this line, for example, this line is going to continue all the way down to infinity. This line is going to go all the way up to infinity. Okay, so that's the range. But if you look at the domain of it, right? Your domain of this graph from negative 65 to negative 35, right? You have values for x. At negative 35, do you have a value? No. So it will be negative 65 less than equal to x less than negative 35. And it will be negative 35 less than x less than equal to, no, it will be here.
Oh,
And less than equal to, it will be 25, right? It won't be less than equal. Because it's not equal to 25, it's less than 25. Here it's not equal to negative 35, well this would be greater than, right? Because from this,
minus 65 is equal.
it would be equal to minus 65.
Oh, because of
It
that.
is cutting it there. And then also you would have 25 less than x less than equal to. You have to take into account the breaks, right? Because at the breaks there's no value of x, so you can't say that's part of the domain. Okay, just something on the side for you to note. Okay, I got that done. Right. Let us now look at should we wait for it? Okay. Let's look at Secans Graph, right? Page 158. So we've done sine, we've done cos, we've done tan. Now we on Secans Graph, right? Secans is basically sec. Sec is what? 1 over sine. 1 over cos, right? 1 over cos. Remember the third letter of each one, right? So, if you look at the page 158, y is equal to sec x. If you let your y-intercept equal to, for your y-intercept let x equal to 0, they get y is equal to sec of 0, it becomes 1 over cos of 0. Cos of 0 is 1, right? You remember that? Yes? Right? So you get a y-intercept of 1. But for your x-intercept, you let y equal to 0. You get sec x is equal to 0, and then you're going to end up with 1 over cos x is equal to 0. So you will cross multiply, right? But then 0 times cos x is 0. You're going to get 1 equal to 0. Does that make sense? No, that's not possible. Right? So how you would solve this? Tell me, okay. You threw that can very hard in the window.
Oh, sorry.
Oh, it's the campaign.
Then, page 159 now. So you see they show you the graph of y is equal to cos x. Eh? And then below that, they got a table, and below that, they give you the graph of y is equal to sec x. How did they do that? Right? You see they gave you values for x in the table. Minus 180, minus 150, minus 90, 0, 30, 90, 150, 180. Right? Different values of x. They solved for the values of cos of that value in the second line. So cos of negative 180 is negative 1. Cos of negative 150 is negative 0.8666. Right? Got that. Then they said 1 over that value. 1 over that value will give you what?
1.
Will give you the sec values. You all understand that? You'll see that? Okay? That's how they're able to draw the graphs below that. Now let's look at negative 90 degrees. Cos of negative 90 is what? It's 0. 1 over 0 is what?
Undefined.
Undefined. So that's how they get these asymptotes that's drawn. All I need you to do, guys, is learn the shape of these graphs. Okay? Look at this thing, you'll see like you have like a log graph on one end or like a hyperbola on two either ends, and then you have a parabola in the center. Right? Learn the shape of the graphs. You'll even see in past year papers, the only thing they'll ask you is plot the graph of y is equal to sec x, right?
So they'll give you this table and
You'll have to work it out.
so you have to learn these figures, these degrees.
That figures is basically you just choose values for between negative 180 and 180, and choose the intervals of it. Like you can choose 30 degree gaps or 60 degree gaps, right?
Okay.
And you'll just basically solve for these values, and then you start to plot it for those values. Okay, so if x was equal to negative 180, your 1 over cos x would be equal to negative 1. Is that?
So you didn't put random numbers, you just said
Yeah, there's just
nothing,
random numbers here. Why?
they're 150 and
I'm saying choose the interval. Make it look easy, right?
Oh.
They just chose, but because remember if they write the whole long thing out, you can fit the page, right? Main things, need to know where your asymptotes are. It'll be at negative 90 and 90.
Always.
Yeah, that's where they get the breaks. See that dotted line coming down? That would be at negative 90 and 90. You can literally just draw the parabola in between, that's fine.
Oh.
The shapes. You're okay with that?
And they won't give us this.
I'll be honest with you, I've never seen them test, like how they test this. Very, very rare you'll ever see something. I've never seen it. The only thing I saw was they asked you, sketch the graph of y is equal to cot x, or y is equal to sec x, or y is equal to cosec x. That was the old question.
Okay.
That was it, right? Good. So that's going to be the exact same thing for sec, cosec, and tan, cot. So page 159, 160, 161. You can highlight it, you can please go through it, right? The shapes of the graphs. Okay? It's cot, right? But you see it looks like on page 162, it looks like an inverse of what the tan will do. See how our waves are going like this? They're on page 162.
Then the other way.
Their one goes the opposite way. So that's an okay one, that's not a bad one, right? And try to learn where the breaks are. So you know in the tables, highlight the points where it shows you infinity. On each table, highlight the points where it shows you infinity. Because then you know where the breaks are. You all understand what I'm saying? In the table itself where they got infinity, learn those degrees for x values, because that's where obviously you're going to draw the breaks and your graphs will be drawn in between those values. Guys, are we all okay with that? Anybody confused about what I said?
Basically, this is that's discontinuous.
The entire graph
Is completely.
discontinuous. Guys, do you understand what I said?
Yeah.
Are we all okay?
Oh yeah.
Okay. So now, okay, as long as that's fine, everybody's okay. I'm gonna move on to number 8 was 7 was 2 graphs. 8 was 2 graphs. What now? 7. So now we're moving on to parabola. So okay, we're done with 3 graphs now, right? We've done sine, we've done cos, we've done tan. You all need to learn the shapes and the values for cosec, sec, cot. Good.
Yeah.
Right. Let's do parabola. And then we're actually done with graphs. The one more type of graph, we look at that in differentiation. Because we're going to work with it there, right? Okay, can I move on to parabola now? Parabola is actually an easy one. I think they did this because they put the hard ones in the middle and then they gave you an easy one to end it off with. So I'm on page 162, right? We are looking at number 8, its formula is
Sorry.
the infinity is the breaks. Yeah, no, the infinity is the breaks. Just learn the breaks values and the shapes. But if you know the breaks, you just draw the shape in each one. Okay? Guys, looking at parabolas, right? Y is equal to ax squared plus bx plus c, quadratic formula, right? Or quadratic equation, sorry. Okay? You're all seen this before, okay? That formula, we've done it, you do factorizing and everything with it.
Yeah.
Right. So, okay, let's do an example of how the graph would look, right? So, okay, for a graph we need 2 or more points to actually plot it, right? So, intercepts. So your y-intercept, let x equal to 0. So you would have said y is equal to 2 times 0 squared plus 2 times 0 minus 12. Your y would have been equal to minus 12. You all agree on that, right? And your one coordinate you would have had would have been 0 and minus 12. For your x-intercept, you let y equal to 0. So you would have ended up with 0 is equal to 2x squared plus 2x minus 12. Okay? How many of you all know the quadratic formula, the quadratic equation? X is equal to minus b plus minus the square root of b squared minus 4ac all over 2a. Have you seen
Or
that?
you can use the calculator, what Lord showed us, to work out the same.
Yeah, you can do that too.
You know the calculator with the k squared you put
Okay,
in?
K method.
Yeah, the k method.
Normally, okay, if you all were solving for x, how you would have done it?
I would say x squared plus
Factorizing,
factorizing. Yeah.
Or you could have used this formula. I'm so sure you would have seen it at some point. Minus b plus minus the square root of b squared minus 4ac all over 2a. Right? How you use this formula is you have an equation, right? Ax squared plus bx plus c. These values here all substitute into the formula. And you'll work it out twice. You'll work out one term with positive, one term with negative. You get 2 values of x. Like how even if you would have factorized this. Okay? If you are factorizing this, you would have divided everything by 2. You would have just said 0 is equal to x squared plus x minus 6. Factors of 6 that give you 1 in the center would be what? 3 and 2. So you would have said 0 is equal to x, 3 and 2. It's a positive value there. Agreed? So this would be positive, that would be negative. If you work it backwards, x times x is what? X squared. X times negative 2, negative 2x. X times 3. So 3x minus 2x, positive x, right? 3 times negative 2, negative 6. If you had to use this formula, so sometimes you get obviously stuff that's a bit more difficult to work out, like how we did it here. How you would have done it here, you would have said x is equal to minus, let's say, even if I use the full formula, right? Minus 2 plus minus the square root of 2 squared minus 4 times 2 times minus 12 all over 2 times 2. So, put it in your calculator, right? The first time you're doing it, only use positive. The second time you're doing it, just go back, delete the positive, put negative. Okay? So this would be x is equal to
2 and minus 3.
I'm so sure it should come out. But remember, this guy is not even done, right? This would be 0 is equal to x plus 3 and x minus 2 is equal to 0, right? Again, right? So x would have been equal to minus 3, x would have been equal to 2. That's your intercepts. So your intercepts here would have been minus 3 and 0,
2.0.
2 and 0.
And then there's a
Yeah, did that?
Yeah.
What number you got? When you put positive, what number you got?
2.
2. And when, now go back, just delete this plus sign and put a negative there. Minus 3. See those values? See these values?
and there's one way. Last method is to use the calculator. with the
Yeah,
equation.
but I don't want to, you know how to do the calculation.
So
method.
okay, I'm stopping this thing, right? Stopping this thing, right?
Don't stop
Pause.
it.
Pause. You must go on.
Second, not second?
Confirm.
Check.
Yeah,
check,
something
check,
to
check.
confirm the numbers you got here, right? Like how I did it to factorizing, I put it in the quadratic equation to confirm this number here. One more way I can confirm is, let me calculate some. Okay, so what you do, yeah, I forgot to update that. So press mode, right? Press 5 for equation, it says EQN. Okay, now look at the types. No, sorry, no. Look at the types of equations you have, right? They give you 1, 2, 3, 4. Number 3 matches what this equation here is. Ax squared plus bx plus c equal to 0. This is the type. So click 3. Now for a value of a, substitute 2. Just equal to. It moved you onto the block B. Then substitute a value of 2 again. It moves you on to block C. Substitute negative 12. Plus equals to. Right? Plus equals to again. They tell you x1 is equal to 2. Plus equals to again. x2 is equal to negative 3.
And the last, what's the last one?
What's the last one?
Just equal one more time.
Oh, that you're gonna see now what that is actually.
That's for your graph.
Your turning point. Actually, I didn't make this is fine.
That's what I'm saying. That also helps with graphs. This one, yeah.
Oh, then it'll help you. Okay, if you know how to do this, no, I actually did the minimum. I have never.
I was saying, the turning points are sort of-
Yeah, so you're gonna see now there's one more thing to a parabola, right? It's turning point. And you see it gave you a x value minimum and a y value minimum, right? I'll show you what that means, right?
So it's calculated minus b over 2a. The
Yeah,
turning point.
minus
Yeah.
0 to it, right? So, guys, pay attention, right? So, okay, I'm gonna leave this here, right? Because I want you to take this down to know that, right? But I'll give you it once I finish, right? So, this is what your graph is so far. Okay. Minus 12. See?
I'm with the old school. Old model.
So, if you want to get back now, you just go at 1 on the wall.
Yes.
Yeah.
Or just press on and clear your calculator. Shift 9. Always just clear your calculator after you do stuff like that. Don't confuse yourself. Shift 9 clear. I think you press option 3 to clear all, and then you press AC. It brings you back to normal. You there?
Equals and then AC.
Yeah, whatever. Just follow the prompts, right? You're there. Shift 9. Follow the prompts after that. Right? Okay. This is our graph so far. Right. Your y-intercept is what? 0 and negative 12. Okay? This is negative 12. It should be negative 12. Right? Your x value is negative 3 and 0. 1, 2, 3. Your other x value is 2 and 0. Now with parabola graphs looks like this. Or like this. Or like this. Or like that. But it's a U shape, basically. Now, we also need to work out, so remember it's not turning on this y-intercept. It's cutting your y-intercept. How you work out the turning point is you do this. So, for the turning point, it's very simple, right? It's not difficult. Turning point, the x value will be equal to minus b all over 2a. Okay? This will be minus, your b value is 2, right? It's 2 over 2 times 2, which would be minus 2 all over minus 2 over 4, which is minus half. That's the x value for the turning point. Right? Your y value, you basically substitute it back into the equation. Okay? So the y value would be equal to 2 times minus half squared plus 2 times minus half 10 minus 12. I want the gives. Your calculators are advanced, right? Now I got it in 27, 2050. No. Ring.
You got which one?
30.
This one?
One they got, but my model was made in 2030.
Yeah.
That's 10 years ago.
Minus 10.5.
Minus?
Oh, wait, minus
12.5. Minus 12.5. So your turning point coordinates is minus half and minus 12.5. Okay? Which is, you know, that minimum x minimum value they gave you and y minimum value, basically telling you that the lowest point of this graph is at a coordinates of that. That coordinate is your turning point coordinate, right? So, say minus 12.5 is somewhere, this is 13, let's say it's here, right? And minus half, that's 1. Yeah. So your graph is going to turn there. Understand what I'm saying? So now your graph would look like this. That's parabola. Very simple calculation.
How many marks? 15 marks.
15.
That's a lot of cool calculation.
So think in okay, that's okay.
It's a lot of calculation because first time you did it, right? So we go very in depth with it. But when you get used to doing it, you after you say 0 is equal to 2x squared plus 2x minus 12, you could have either just shown this equation and shown the values of x. See, I'm not even going to ask me if I just use the calculator and I went from here to
You're
here.
taking us
I
like
think
10
they
seconds to
they
do the-
because these calculators, you know what they tell you at the start, no programmable scientific calculators may be used and stuff. You know whether these count as that and stuff, but what are you learning if you're just substituting it to a calculator? You learn none of the method, right? These were made to obviously make life easier for people who use these calculations.
But you need to verify and check.
You came to learn what the calculator did, so you understand when you put these values in the calculator what it did. So you will lose marks because you're not understanding the method of what happened. Yeah? As a story there. This here is, so you can show your point here, this would be 2 and 0, this would be minus 3 and 0. Your turning point coordinate would have been minus half, minus 12.5. This coordinate here would have been 0 and minus 12. And this graph is called y is equal to 2x squared plus 2x minus 12. Does everybody understand what I did there?
Why?
No, I'm not saying now what I did, but I mean
Yeah.
The whole thing.
Oh.
I just got a question, right? So you had 4 shapes of the parabola, right?
yeah.
Yeah. One going this way, other
One
way,
the other way.
left and right,
Yeah.
right? What would determine
By looking at it.
by looking at it?
So if you have it in this form, y is equal to ax squared plus bx plus c. If your a value is positive, it'll look like a u. If it's negative, it'll flip the other way.
That's fine,
right?
right?
Now you know left and right.
Yeah.
Left and right is, I'm coming to that part too, is if x is equal to ay squared plus by plus c. Swap the y and the x. Instead of having y is equal to ax squared, you have x
that's
is equal to like an
okay.
inverse.
Inverse,
You swap the x and y.
That's the
coordinate.
equation they'll give you.
yeah.
Right.
Yeah.
So you see it on page 165 at the top, right? If that a value is positive, it looks like this. If that a value is negative, it looks like that. Okay? If the
The a value would still be the x, huh? If
look at the top of page 165.
x minus y squared plus 3y plus 4. Same one.
Top of page 165.
Yeah, that's not
Oh, yeah, yeah, the form x is equal to minus ay squared plus by plus c. Right? That's the same thing I told you how that equation would look like. And then if you look at, see the example below that? When they made it in terms of x is equal to y squared minus 3y minus 4. Your a value is a positive value. Yes? See the graph they obtained? The shape, it looks like a C. So in terms of that, that's how you would get. But remember, all that will come when you do the calculation.
Yeah.
Okay, as you do the calculation, but in terms of visually seeing it, that's what you will know. So parabolas are very easy, guys. It's not difficult. Remember there was two forms to it. You could either get it like that, or you could get it in the form of x is equal to a y squared plus by plus c. So I'm just gonna write next to it. These here would give you these forms. These here would give you those forms. Okay? Right. That's the two forms you could ever see it in. Calculations will be exactly the same. Only thing, when you are doing the inverse one, right? Remember with this type of one, your x-intercept, you let y equal to 0. So you get one value of x. But you will get two values of y because it's turning twice on the y-axis. There. Okay? In terms of your turning point, this formula will now be for y. It won't be for y is equal to minus b over 2a. You get the value of y, you substitute into that equation, you get the value of x and the coordinate.
And quick one, right? So if for the top one, a is minus, obviously it's going to be upside down, right? The top one. The bottom one, if a is positive,
You get the c.
c, and it's negative, a is negative, you get that.
Yeah. So, guys, is anybody confused about anything here? Okay. Yeah.
No, we're good.
Right. That brings us to the end of math graphs, right? So, okay, so you also see on the bottom of 165 they tell you cube functions. These are discussed in module 6, paragraph 6.5.4. So when we get to differentiations, we'll discuss the one more. So how many graphs do you need to know? 9 types of graphs. Inside some of those types, there's a bit more, right? So from the top, first graph, straight line. Yes? Second graph, ellipse. Third graph, circle. Fourth graph, rectangular hyperbola. Fifth graph, hyperbola. Sixth graph, logarithmic and exponential graphs. Seventh graph is trigonometric graphs, which are your sine, cos, tan, sec, cosec, cot. Then you have parabolas. And then lastly you have cube functions. You all need to remember how the shape looks, the general formula, and if you have to draw it, what values you would need. For a straight line, you just you need 2 points, right? To get your straight line. For the ellipse, remember the formula, you get 2 values for x, 1 value for, 2 values for y. But the difference in the formulas is ax squared plus by squared equal to r. Okay? Equal to c squared. That's the formula, general formula.
For your left is ax squared plus bx squared plus c.
Ax squared plus bx squared.
Meanwhile,
That's it. Ay
that's the C. A squared plus B Y squared. That's
Ellipse.
Yeah, plus by squared, right? Ax squared plus by squared is equal to c. Circle, you have the same a values. You get ax squared plus ay squared is equal to r squared, right? Rectangular hyperbola, x times y is equal to c. Hyperbola, What I got? What's the problem?
X squared minus 3y squared equals E.
Right? That. Then after that we got our logarithmic graphs. Now remember there's a few over there. You get y is equal to k. Y'all know it, right? Yeah, right? Then you get after that our trig graphs. Sine, cos, tan. Remember the general formula of it would be y is equal to a sine bx plus c, all of that plus d. Remember what each value does. Then you get your parabolas. Parabolas are generally simple. You got your general formula. Remember the turning point formula. Minus b over 2a. They call it sometimes the axis of symmetry. Because remember, symmetrical is, it's basically a mirror image about an axis, right? If this is my turning point, and follow this line, right? On the left hand side, should the left hand side be directly symmetrical to the right hand side? Because the turning point will be the middle point where it cuts the graph. Cool. Right? Monday we're gonna start with differentiation. Tomorrow we're gonna do